This video tutorial will illustrate how we can model mixed materials in Adapt Builder 2016. And in that version of the software, the introduction of generic materials and generic components was introduced to give the user the ability to not only model these native to the Adapt environment, but also to import those other materials other than concrete from different softwares using our integration console. So we'll go ahead and get started. In this example, we're going to build the model using the build functions and build tools within the software. We're not going to import a model. We're just going to simply build the model. So we'll go ahead and first of all, we're going to set up and establish our concrete structure. We have a 2-level concrete structure, and then we have a 10-story braced frame steel structure above that. We'll go ahead first, and we're just going to enter columns. So I'll go ahead and change the dimension of the perimeter column here. This column will be a 20 by 36 inch column. And we're going to then copy that and offset that by 36 feet. So we'll go to Modify, Copy, and Move. And we're going to use the All Transformations in Plane tool, and we're going to do this in the positive direction, so we'll just say 36 feet, and we're going to copy. This column will be 20 inch by 20 inch square. I'll change that, and then I'll go ahead and modify, copy, move that. This copy will be 20 feet, and then we're going to go ahead and copy the last column. We could also use the copy and move toolbar. We're choosing just to use the pull down list here. So we'll go here, and this will also be 36 feet. We'll copy this over, change the size of this back to a 20 by 36. Now these columns are going to be also located on the opposite side of the structure, which will be 92 feet. So I'll take all of these, I'll modify, copy these, and we're going to move these down in the negative Y direction, 92 feet. We'll say copy, and we're now going to use reference lines to establish where we're going to have some core walls and shear walls. So these in essence are grid lines, since we don't have grid lines that have been imported from, let's say, a CAD file or from a Revit model. We want to use just reference lines to be able to draw certain components. So this reference line is going to be copied down, again using the copy and move option, the same distances as the other columns, just in the Y direction now. So this will be a negative 36 foot copy. We'll do that one more time. However, this was going to be now a negative 56 foot copy. We now have those established. I'll use some cross reference lines, and I'm using the Snap Orthogonal tool in order to establish these orthogonal grid lines. So we're going to now build our walls. The walls are going to be 12 inches thick. We're going to have a core established at this location. So I want to use the snap to intersection and snap to vertices of components in unison. And we'll go ahead and create the core. And you can see I missnapped this particular wall, so I'll just grab that and move that back. That's not a big problem to solve. And we'll go ahead and finish the wall modeling. So we have a wall on the exterior here, and then another wall on the exterior there. This will become our concrete structure. So for the concrete structure, I'll go ahead, and I don't want to really see these lines anymore. I want to hide those, so I'll just select all of the lines, and I'll use the option to hide the selection. This is on the selection toolbar. I'm now going to create a slab. I'll go ahead and select the option to build a slab or create a slab region, or I can select build structural components slab region. And again, using the snap to endpoint with snap to vertices of components turned on, we can go ahead and create a wall from the outer corners of these perimeter columns. this particular slab, which will be at the lower level. There are two concrete levels separated by 13 feet. This is going to be an 8-inch slab, which is shown here. And we now have our concrete structure built, and I'm going to now replicate this vertically. Before I replicate it, I want to use the Story Manager toolbar to set up my different levels. So we'll go into the level assignment. You can also get to level assignment from the build option under construction aids, level assignment. And we're going to rename these levels and also assign the level height. So we'll call this base. The second level we're going to call P1. The next level up we'll call podium. These levels are going to be 13 feet. So I'll just go in and select 13 here and also here. And then we're going to add levels above the podium. So we're going to add 10 levels. And I'll go in and just rename these particular levels, and I'll call this S1 up through S10. So we've established the levels in the steel structure, again S1 through S10. Those are bearing on the concrete podium, and the level height for those steel levels is 12 feet. So we'll go ahead and close that. I'm now going to save the model. So we've saved the model. The name of the model is shown at the top of the screen. And we're going to do some replication now vertically. If we're in Story Manager toolbar, you can see that we're working in single level mode. If I use the view toolbar and I go to either a front view or a side view, we're working on level P1. That's our active level, which is highlighted, and we show the levels above and below the active level. So I'm going to just select all of my concrete components, and I'm going to replicate using the copy and move toolbar one time. I'll go ahead and copy these up one time, and we can see the walls and the columns copy up. If I navigate up to the next level, which is the podium, now the range changes. I'm now at podium, the lower level is P1, the upper level is S1. So at the podium level, we're going to use an 18-inch slab. And looking at the full structure, we've only now modeled the concrete. So you can see here we have the concrete model. If I show a 3D view and just show the shading, this is currently what our model looks like. Now we're now going to begin establishing the components for the steel structure. And before we assign both the generic components and the generic material for the generic components, I'm just going to use concrete components so that I have the steel structure modeled, and the different components are represented by something. So we'll just use the default concrete components to do that. I'll go ahead and go back to a wireframe view, and we're going to go back to single level, and I'm going to navigate up to level S1. Now on S1, I don't have anything to reference, so I don't know where my steel members go because I can't see the level below. If I go back to multi-story structure or full structure view, I can now see everything below, but my active level is still S1. That means that everything that I model is going to be referenced from plane S1 down to the podium. And so now we have the proper settings established in order to model the steel structure. So the first thing I'll do is use the option to add a column. I'll create columns, and in this case we are going to be modeling a material of concrete just temporarily, but I do want to represent these by the right sizes, let's say. So for this column, the columns are going to be 10 by 10 in the structure. The columns are also going to have a pin or release, rotational release at the base of the columns. So if I go to release, I want to release at the bottom of the columns. I'm going to release rotation about R and rotation about S. And we'll go ahead and select OK. And I'm now going to establish the placement of my components. Now I have too many snap tools turned on at the moment. I'll turn off snap to vertices of components, and we're going to establish now the column placement for the steel structure. So we have two sets of columns. These are going to be the braced frames stacking on this wall core below. So we have two columns on either side. We're also going to have columns out on these outer concrete columns. Those are shown there. We'll have two columns on the other side. And the shape of the steel structures will be like a cruciform type shape. I'm now going to take these columns and I'm going to offset and copy these the distance down where we're going to have additional steel columns. So I'll take those two using the modified copy move option. We're going to copy those in the negative direction, in the Y direction, 18 feet. We'll say copy. So these are actually planted columns which are bearing on the concrete structure, and we'll do the same for the other sides. This will be in the positive Y direction. And this will be in the positive X direction, and then the last copy will be in the negative X direction. So we'll now use negative 18 and copy. Now, one thing we may want to do, if we want this to be more realistic, in other words, if we want the wall to be completely underneath the column so that they're bearing on wall, instead of having some analytical representation of the connection, we can take these walls, because we're working in multi-story mode. If I select these walls, that will select the walls both at the podium level and at the P1 level, and that's due to me being in multi-story mode. And I'll go back and I'm going to turn on the option for snap to midpoint and snap to vertices of components, and I'll just stretch these walls out so they encompass those columns. I'll do the same thing on the opposite side. Okay, and the in this case we'll do the same, because this actually intersects at the exact same location, so we're just representing this as a more exact condition. And we're going to take this and move that there, and we'll take this one and move that over there. So we have a slight overlap. That will complicate the mesh at the concrete level, but the program will still be able to mesh that just fine and be able to handle that meshing at that location. We'll do the lower level. Okay, so we now have the columns established for our steel structure. If we go up one level, I'll go back to single level, and now we can see that we're at the steel level. So this is S1 to be exact, and we're now going to establish some beams. So I'll go ahead and, again, using concrete components, we're going to use a 21-inch deep beam, so we'll just use 12 by 20 in this case, and we're going to model the location of our beams. If you make any mistakes here, it's easy to go back and clean up any mislocations for snapping points. So like up here I have a problem there. I'll go back and make that change once we're done adding these beams. So we have our main beams on column lines, and we also want to model a few joists or infill beams, so we'll go back. I'll just use the same beam size. I want to be able to snap to the center or the midpoint of that beam, so I'll turn back on my midpoint option, and now I can snap to the midpoint of this beam. So we'll just use one infill here in this direction, and then we'll do the same for this direction. If you needed to break it into third points, then we have again the option to copy and replicate over specific lengths within a bay. In this case, we just have those split in half. So this becomes our beam layout for the still structure. I want to apply wind loading to this structure. That will be our lateral load that we're going to apply. In order for us to apply wind loading and to take advantage of the automatic wind generation in the program, I need to have a diaphragm established. So because the program will apply loading relative to the extents of the diaphragm. So we're going to use what's called a dummy slab in this case. And the dummy slab, I'll go ahead and just say that the dummy slab is 4 inches thick. And under the materials pull-down menu, we could go in and establish concrete material assignments for the dummy slab. The only reason I'm adding it is, number one, to account for the self-weight of the still structure of the infill metal deck / concrete slab, and also to allow us to have the proper wind forces be applied automatically to the structure. So really just a twofold purpose there for this. I'll just use the location of the corner of these still columns as the edge of slab on the still structure. So that's the slab for the first still level. I'll go to a three-dimensional view, and we just want to confirm that the release has been made on the bottom of the columns. So if I double-click a column just randomly and I select release, we can see here that the column is actually modeled above. So we actually need to go back and reassign the rotational release here for these columns. This is grayed out because of that. And so what I'll do is I'll do this comprehensively for all of the columns, and we're also going to release the beams. If I double click on a beam, you can see that we don't want there to be any moment frame action for the beams. Everything is being drug into the braced frames, which we'll establish here in a moment. But I can also see that for beams I can release rotation about the first or the second ends of the beam. So rather than do that one by one, I'm going to select all of my columns. I'll just use select by type, column. Whenever we make multiple component changes at the same time, we're going to use modify item properties. It can also be found with this icon here under modify item properties. I'll select columns, and we're going to release rotation at the bottom. So I'll use these two check boxes. I'll check those, select OK, and again if I double click to confirm, double-clicking to confirm, we can see the releases have been created for the columns. So if we go to release, we can see those there. And the columns can be done individually if needed as well by just double-clicking on the component and selecting the release tab. We'll do the same for the beams. I'll go to select by type and select the beams. And from the modify item properties, from the beam tab, we can go ahead and modify the rotation about S, and again on the second end we'll do that as well. Select OK, and then we'll just confirm by double clicking, and we can see that rotational restraint has been released. Now we also want to model the we want to be able to model the braces. So in order to model braces, I'll go back to a plan view, and I'm going to create a brace at this midpoint. So I'm going to, in essence, create two columns which are connected at this point but offset. So we'll go to the option for creating a column, and I'll just place a column at this location. And if I go back to my three-dimensional view, that column is just simply oriented vertically. It's aligned with the same XY coordinates at the top and bottom, but if I double click on the column and I'll go to the location tab, I can now offset the top and bottom. So I don't want to offset the top, I'll offset the bottom in the X direction, and the offset, the bay here is 20 feet. So we're going to use an offset of negative 120, and we'll select OK, and that will shift the column into a braced condition. I'm also going to use rotational releases at both ends of the brace. So we want to go ahead and make that change. And now I'm going to create a new column. I'll go ahead and create column. This column, however, if I go immediately to the properties menu under location, you can see I'm unable to change the properties until the column is in place. So we'll go ahead and let's go back to a plan view, and I'm going to enter this column at this location. So we now have two braces shown, or modeled in this case, and we're also going to now create a new column, and I'm just going to arbitrarily set this at some position. So I'll just place it here, and then I'm going to double click on the column and change the offset from a negative to a positive 120. I'll take that column now and just move it back into the position that I want it to be. And now I can also copy and move the column. Instead of copying it by graphical or by entry using XYZ coordinates, I can do this by translation. So we'll go to Modify, Copy, Move, Translation, and I want to move this from its position here down to the position below. We'll say Copy. And if we look at a rendering of this, we can see where those braces occur. And those braces should retain the same rotational releases at the ends of the brace. So if I double click on the brace, go to release, we still need to make that change here. So we'll release that rotation. We'll do the same for this one and also this. Now it's clear that for this particular steel structure, we would need a lateral resisting system in the Y direction. We're not going to model the braces in the Y. We're just assuming we're looking at the X direction, but we might have the same configuration of braces in this bay here and this bay right there. We've now established the first level of the steel structure. I'm now going to just simply select these components, and I'm going to copy them vertically and replicate them 9 times. So I'll go to copy up. We're going to do this 9 times, select OK, and I'm still in single level mode, but if I navigate upward, we can see that we have the same components at all of our levels. And if I go to the full structure view, I now have the entire model shown, and we can see that steel structure bearing on the concrete. Now, Adapt Builder is a program that's used for the design and the analysis of concrete structures. We can now analyze mixed components, as we discussed at the onset of the video. However, we can only design concrete components in the software. So the purpose here really is to be able to establish loads on the structure and bring those loads down to the transfer level so that we can design the concrete with relation to the reactions that are bearing on it from the steel structure above. So we have our frame that's been built, and I want to confirm whether or not the rotational releases were copied upward. If we double click on a column, we can see that we don't have releases here. And also for beams, if I look at the releases, there's no releases. Same thing happens for the braces. There are no releases. This brace has one. It may have been set previous, but if we look at another released condition, we can see, for example, this brace does not. So we're going to comprehensively assign all of our releases to all of the columns above the and the braces above the concrete in the structural steel levels. Before I do that, I'm going to use the option for select set view items. We're going to turn off the slab regions, and I will also turn off my beams. We'll kind of tackle the columns and the braces first, and we'll go ahead and go to a side view. I'll just select all of these components at one time. I'll go back to modify item properties, and for columns we're going to release the rotation at both ends. Select OK, and again we'll just select one of these columns to check the releases. We can see the rotation is set there, and for the brace the rotational release is also set. So the columns and braces are done. We're not doing that in the concrete structure because we're counting on that joint stiffness for lateral integrity and stability. I'll go back to my select set view items. I'll turn off now my columns and walls, and I'll select my beams. And so if I just select all of the beams at once, modify item properties, we'll go and release for rotation, again using this input. For make sure you've selected the beam tab. We'll select OK. Double checking, I'll just double click on any of the beams. We can see that's shown there. To re-establish the entire model in the view, we can use this option to go to default display. The default display is set within the select set view items, where you have the option to select save as default. So the model is now in place. However, everything above the podium is now it's set as concrete. We want to make sure that it's still, and that we assign components that represent those particular still components. So the first thing that we want to do is we're going to go to the material pull-down menu. Under generic, I have this option for still with associated properties. The user can modify the properties to values that satisfy the requirement. We'll select add. We have to select add in order to have the ability to assign this to a component. We'll select OK, and we're now going to define our generic components. The generic components in the program are defined using what we call a bounding box. In other words, if we model a wide flange column or a wide flange beam, the representation graphically for that component is not the true representation of the geometry of the beam or the column. It's simply an out-to-out dimension or a bounding box. So if the beam is 10 inches nominal deep and the flange is 7 inches, our bounding box would be an A dimension of 7 and a B dimension of 10. So we'll go ahead, under the build pull-down menu, we'll select the section type manager, and we're going to add a new section. And this new section we're going to say is steel columns. And I'll go ahead and add two more. This is going to be steel braces, and the last is going to be steel beams. And you can have as many of these definitions as needed for the project. So for steel columns, we want to define the type as a column. We have the option for beams and walls also. This is a column. For the shape, it's going to be a generic shape, and that will filter the properties that are shown below. For material, these are going to be steel material. The bounding box for the column, we're going to assume that this is a 10-inch flange and a 10-inch deep member. We also need to establish an area, so I'm just going to put in some fictitious numbers, but these would actually match the properties of these columns that we might be using from the AASC manual for steel construction. So for the moment of inertia about RR, this would be like the strong axis. It would coincide with XX per the AASC manual. We'll just say this is 300, and the other direction I'll say is 150. Polar moment of inertia. And then we have the CG position, which is the distance from the extreme fiber in the direction either positive or negative. So the CG positive in the RR direction, again this would be the XX would be 5, this is 5, and these are all entered as positive values. So if I select OK, we're going to assign the columns now. So again, I need to do some filtering. Rather than using the option for select set view items, we'll introduce you to a new feature that you may or may not have used before. This is user interface structural component toolbar, and this is the display toolbar. This allows me to just quickly snap on a button and filter the display off or on. So I'm going to turn off the slabs. I'm also going to turn off the walls and also the beams. So we're left with the columns and the braces. We'll go now to a side view. I'll select all of my still columns, and some of these may be more difficult to select. So what I'll do first is I'm going to filter out the braces. I'll select window the braces, or window select the braces, and I'll use the option for hide selection. Now I can go back and easily select all of my still columns. We have our columns selected. If I go back to 3D view, you can see that they're selected out of plane as well, and we're now going to assign those the material that we just created, or the component that we created. So we'll go into modify item properties again. For modify item properties, we're going to select the option for design group, and this will be still column, and we'll say OK. And if we just select one of the columns, so I'll double click on this column, we can see that the section type is a still column, the material is still 1. The rest of this gets grayed out because those are there and reserved for concrete. So now that we've assigned it a generic component, this becomes inactive. And so we've done that for now the still columns. I'll go back to my default display, and we're going to do the same thing. We're going to filter out until we get to the braces. Before I do that, I have to define the braces. So I'll go back to my option for build section type manager, and we'll go ahead and change the still braces. This is going to be a column component type. We don't have an option for brace, so it's a column. The shape will be generic. The material is going to be steel, and these are going to be HSS 6x6, so square tubes. The area we'll say is 10. Moments of inertia, it's symmetric, so these are identical. We'll say this is 50. The polar moment of inertia, I don't know what that is, so we'll just make up a value there. And then for the CGs, we'll use this option, 3 inches in both directions, positive and negative directions. So that's the still brace definition. We'll do the still beam definition also. The type will be a beam. It's going to be a generic beam with steel as the material, and for the bounding box for the beam, we'll have a 7-inch flange, and the depth of the beam is going to be a 21-inch deep beam. The area of the beam will be 275 inches squared. The moment of inertia will be 400 and let's say 75. And then the distance here for the R direction, which is half of the bounding box A, will be 3.5. And this will be 3.5 as well. And then the other direction is going to be 10.5. We'll select OK. That will store those sections that we've created as generic sections, and we'll now define the rest of our components. So going back to this front view, I'll select my braces. We'll go to the modify item properties under columns. The design group will be still braces, and you can see the change in the size of the brace shown graphically. This now represents the bounding box dimensions. If I double click on the brace, it's shown there. I'll turn off my columns and show my beams now, and I'll select all of my beams. And we've simplified. We realize that all of the beams are probably not going to be this size, but we've only selected and created one beam group. So we'll select still beams for the design group, select OK, and if I go back to my default display, we now have a structural model which represents both concrete and steel. The next step will be to apply loads. So we're only going to consider lateral load. Again, we simply want to show how to get the reactions into the structure, the concrete structure, and analyze at one podium level for the reactions being dumped onto it from the steel structure. So in order to apply lateral loads, we have multiple options. This video we're going to show how to apply lateral loads for wind using the wind load generator. And I'll go to loading. We're going to add loads, and we'll use the wind load wizard. We're only going to add wind in the X direction, and we're not going to consider eccentricity. We're just really simplifying this so we can understand the behavior and the process that we can follow to model this type of a mixed structure. The wind direction will be 0 degrees. That corresponds to the global X direction. The exposure height is going to be from S10 to base. Now, if we want to assume that this is mixed and we're going to apply wind on the steel structure separate from the wind on the concrete structure, then we can always choose to shift the ground level to, let's say, podium, for example. In this case, we'll just use base for our exposure range. The wind pressure parameters are shown here. We'll go ahead and enter our wind speed and the different directionality, topographic factors, the windward and leeward gust coefficients, or coefficients, and then the gust factor. That will populate the wind pressures shown at the different heights at the bottom left. These wind pressures are then converted into windward and leeward forces, and those forces are then calculated as line loads and applied as line loads on the edges of the slabs. You can see that this particular setup results in a wind load case called wind P0. So I'll go ahead and I'll apply those forces, and you can see that for each of the levels we have line loads. The line loads become disconnected from that input. So once we've created the wind loads, the user can go in and these just become a regular line load. You have the ability to modify it using the property box for the wind load. If I go to a single level, you can see what the wind force distribution looks like. We just have a windward force acting on each edge of the slab, and then a leeward force acting on the opposite edge. And that happens or occurs at each of the different levels. So we'll go ahead now and we're going to set up a load combination that evaluates only the wind load. I'll go to loading, load combination, FEM tabular. We have some default combos here. I'll just go ahead and select no code check as my analysis design option type. This just simply means that for this particular combination, the program will not design reinforcement for the results coming from this combo. So we'll add this new combo. I'll just call this lateral test, and we're going to assign this as 1 times wind P0. And I could create another test. I could add one more. This is called lateral test negative, and this might be negative 1. We'll say OK. And the next step will be to mesh the structure and then to analyze. So we'll use the automatic mesh wizard. We'll go to FEM, automatic mesh generation, and we'll mesh the slabs. Once this structure has been meshed, we can now go ahead and analyze the structure. So we'll go to FEM and we're going to analyze globally. We're analyzing assuming that everything is uncracked in terms of the concrete. We could apply stiffness modifiers using usage tools in the software. That's covered in a separate video. We're going to turn off the option for vibration analysis. I'll select both of my lateral load cases. The options to include global analysis results are grayed out because we are running the model globally, so we don't have any options. This becomes available when we go to a single level and want to apply reactions to a single level. So we'll say OK. Once the analysis has been completed, we'll select yes, and just to feel good and have a sense of the results and the accuracy, or let's say the proper behavior of the results, I can always use my option for the result display settings to show some of these results. And for example, we can show the axial forces in the columns to kind of see the brace behavior and see the buildup of the tension and compression loads and the reversal due to the load reversal. So if I turn off my display of slabs, and I might want to turn off the display of the beams as well, and I look at the loads in the columns, if I go back up to the option for column axial forces for lateral test, you can see that there's a buildup here of force in the braces. So one brace, the value is negative, one brace it's positive, they're the same value, and those brace forces and the axial forces in the core, the corner columns of those braced frame towers will build as well. And if we look at the bottom, we have one brace which is in compression, one which is in tension. If I reverse the load combo, the actions flip and it's the same magnitude. So there are ways where we can gather and equate the forces and do some quick validation. So this is how we might generate graphical results to look at actions in the different components. Now, to confirm the releases that we had made for columns in this system, if I go ahead and just navigate using the Story Manager toolbar to one specific level, for example, and for either of the combinations, the lateral combos, we're going to use the option under column, under actions combinations. We can look at, for example, moments in either direction, axial forces. We can see we have very little axial force and zero moment in those particular columns. All of the action is really happening here in the braces and the column towers that are connected to the braces. So additionally, if we wanted to check deflections for any slab, if I go up to the top and I select the option for deflections, for example, the global deflection or the X direction deflection, we can see the different contours deflection-wise at a particular slab. We can also use the options for component deflections. If I scroll back to columns and I look at the RR or SS translational values, we can see deflections at particular locations, top and bottom of columns at this particular level. Globally, if I select the option for FEM, View Analysis Results, we can get a sense of the deformed shape of the structure, which is highly exaggerated in this particular view, but if we use this option for 3D, we're going to see this upper level shift to the right, and then if I switch the load combination, this will be in the opposite direction. So we can study the behavior of the model and the results using some of these reporting tools. Now ultimately, in terms of the workflow, we're now going to navigate back to single level mode, and in single level mode I want to scroll down to the podium level. So I'll scroll down to my podium, and we have this podium level which we said was 18 inches thick, and the purpose now for this particular tutorial is to show how do we get the reactions onto the podium level. Our purpose might be to design the reinforcement and to check serviceability and strength requirements for this podium. But we have this still structure above. One of the more complicated ways of doing this is to have multiple models, one still model, one concrete, and have to manually or somehow import an input file to accept the loading from the still structure. Now we can do this all in one with Adapt Builder 2016. So in single level mode, if I reanalyze the structure from FEM Analyze, I now have the option to include global analysis results. In our example, we only ran lateral loads, so we want to go ahead and include the lateral reactions. If I select the option to include lateral reactions, the load case is the wind P0 load case. we're going to include all of the reactions, meaning axial, bending, shear, and also the solution that we ran globally was for the uncracked stiffness modification case. Notice that if I select the option to include load takedown, nothing appears because we have not executed any of our gravity loads. We only ran these tests for lateral. So I'll go back and include the option for include lateral reactions, and we'll select OK to run this model. If I select OK, the program has re-executed the analysis of this particular slab with the presence of the lateral effects from the still structure. And again, we can use the options for the analysis results from the result display settings to view results relative to that analysis. Additionally, the user can set up design strips and support lines, which are covered in another video located on our YouTube channel, and those videos show how to set those up and how to design sections related to global or a single level analysis. In conclusion, if you have any questions related to this video or how to set up a mixed model, please contact support@adaptsoft.com.